So today we're reviewing quadratics. So the first thing we learned when we did quadratics was how to graph from a table of values. We have learned other things, but just to make sure you remember that, kind of just make your XY table. And again, start from somewhere. A lot of times I like to use 0. So we put a 0 in here. These are both going to be 0 here, maybe. And so we get 3. I like to graph them as I go so I can kind of see what's going on, because remember, we got to find what I call kind of the turning point or whatever. So if we put a 1 in, 1 squared is 1, plus 1 plus 3 would give me a 5. So 1, 5. I ought to put a negative 1 in to see what's happening. So if I put in a negative 1 squared is 1, minus 1 plus 3, so that would give me 3. So negative 1, I'm going to be at 3. I put a negative 2 in. Negative 2 squared is 4. 4 minus 2 would be 2, plus 3 would give me 5. So now here. So really kind of the turning point must be somewhere in here. So like you might want to put a negative 1/2 in to see what happens. Negative 1/2 squared would be positive 1/4 minus 1/2. So that would be negative 1/4 plus 3 would be 2 3/4. So kind of right in there somewhere. So it's going to look like that kind of would be my graph for that quadratic. Next, we learned some other things we could use. We can use the axis of symmetry, so we need to remember that formula. X equals negative b over 2a to find the axis of symmetry, and then we can find the vertex point, maximum, and then graph using that information. So if we want to use that, we're going to get x equals negative, in this case b is negative 4 over 2 times 1. So negative 4 divided by 2 would be negative 2, and then the opposite of negative 2 would be 2. So x equal 2 would be my axis of symmetry. So that's one of my answers, so I'm going to box it in. To find my vertex point, I'm going to put a 2 in here and do the math. So 2 squared would be 4. Minus 4 times 2 would be 8, minus 4, so 4 minus 8 is negative 4, or yes, and then negative 4 minus 4 would be negative 8. So my vertex point is going to be 2, negative 8. I'm going to graph that. 2, negative 8, 1, 2, 3, 4, 5, 6, 7. So right off the graph it goes. So about there. And is it going to be a max or a min? Well, again, you can remember by just telling what the coefficient of the x is, it's going to open upward, so it is a minimum point. So that's another answer. So there are my 3 answers. Now I need the graph. So I can put probably a 0 in to see what happens. So I'm going to get negative 4 when I put a 0 in. So 1, 2, 3, 4. Which means I'm going to have 1, again, this is 2 over here. That probably would be enough to graph. If you want to put another point in, you can. But I think we can probably graph from that. And there we go. Solve by graphing is where we got to be a little careful and try to be accurate, because we never know if it's going to be a whole number or not. But I probably would want to use the axis of symmetry equation to do this one. So x equals negative, b in this case is 8, over 2 times 5, which gives me x equals negative 4/5. So probably not going to be a fun one to work with. So that's my axis of symmetry. If I'm going to put that back in, negative 4/5 squared is going to be positive 16/5, so I have 5 times 16/5, so those are going to cancel, just leaving me 16, plus 8 times negative 4/5 is going to be negative 32/5 minus 1. well, let's do the 16 minus 1, I guess. I could do that and get 15 maybe. Oh, wait a minute, this should have been 25th, so that'll be 16 over 5. Good, so that'll make it a little easier. So 16 minus 32 would give me negative 16 fifths. And this is minus really 5 fifths. So that gives me negative 21 fifths. So my vertex point is negative 4, comma, negative 4 and 1/5 if you want to think of it as that. So it's going to be really difficult to graph, so I'm probably not a good one to solve by graphing, but so negative 4 fifths, negative 4 and 1/5. 1, 2, 3, 4, especially with this thing, it's kind of hard to graph anything there. So somewhere close to that, I guess. If I put a 0 in, I'm going to get negative 1, so that's pretty easy to find. 0, negative 1, which means I have 1 here. If I put a 1 in, 1 squared is 1, so that's 5, plus 8, minus 1. So that's going to give me 12, so that's not going to be super helpful. So I'm just going to hope that I can get it here with my and it looks like the solution is not going to be a whole number. It's going to be between 0 and 1 and between I think I kind of messed this up here because I forgot I was only 1/5 over, so this one needs to come back a little bit. So let me fix my graph a teeny bit here, get my eraser. And so this was really, when I look at where this point here is, this was 4/5, so it's 3/5 over, so it's going to be 3/5 over this direction, so it's probably only going to be about right in there this graph should be. So it's a little skinnier than I thought. So that looks like it's between negative 1 and negative 2. So, not a nice one to graph. That's one reason why we learn other methods here, because graphing is not super helpful in some cases. Sometimes it is whole numbers though. So, alright, now we're going to solve by completing the square. So remember, we need to isolate the x squared and x terms. So I'm going to subtract 32 from each side, giving me x squared plus 12x equals negative 32. Take the b term, which in this case is 12. Take half of it and square it, so I'm really adding 36 to each side. Again, probably a good idea to write that step out. And I'm going to factor this because now it is a perfect square trinomial. Simplify this side, and this is what I get. So now I can take the square root of each side because I have a perfect square here. The square root of x plus 6 squared is x plus 6 equal plus or minus 2. Subtract 6 from each side, and I get negative 6 plus or minus 2. So I get x equals negative 6 plus 2 would be negative 4. Negative 6 minus 2 would be negative 8. So those would be my two answers there. And solve using the quadratic formula. So again, remember the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. Just putting everything in their place again and making sure it's set equal to 0 first. Negative 8 plus or minus the square root of 8 squared minus 4 times negative 4 times positive 3 all over 2 times negative 4. So this gives me 64 here. Negative times negative is positive, so that is 16 times 3 would be 48. So add those two together and it gives me 112. So that's what I'll be taking the square root of. So I'm going to end up with negative 8 plus or minus the square root of 112 would be 10.6 all over negative 8. So negative 8 plus 10.6 would be 2.6 divided by negative 8. would give us, where's my answer at? 2.3, is that what that is? Let me divide and see. Oh no, negative 0.3. Negative 8 minus 10.6 would really be negative 18.6 divided by negative 8. Negative divided by negative would make that positive, and that's the one that's 2.3. So there are our two answers.